Hey everyone, and welcome to The Explainer. So, have you ever wondered what actually separates the people who merely try to learn a complex new skill from the ones who achieve literal Olympic-level mastery in it? Well, today we are going to synthesize two incredibly powerful yet totally distinct frameworks into a single master formula for achievement. First, we're going to look at the biological hardware of our brains using John Sweller's cognitive load theory. Then, we're going to pair that with the psychological software you need to sustain excellence, diving into Angela Duckworth's really groundbreaking concept of grit.
To give your brain a quick, clear roadmap of where we're headed, here is our agenda for today. 1. How human brains learn. 2. Managing cognitive load. 3. The power of grit. And 4. Developing gritty habits.
Okay, let's dive right into this because, we've all been there, right? You're staring at a massively complex math problem, or trying to learn a new language, or reading some dense technical manual, and suddenly, your brain just shuts down. It feels physically impossible to absorb even one more fact. So why does that happen? Well, to answer that, we really need to understand the fundamental biological hardware of the human brain.
Section 1. How human brains learn, focusing on cognitive load theory.
This brings us to the pioneering work of educational psychologist John Sweller. His research maps out this very specific three-step chronological process for how we actually acquire information. Step 1, your working memory processes the new data. Step 2, learning happens as your brain successfully transfers that data. And Step 3, your long-term memory stores it into these highly organized structures called schemas. Sounds simple enough, right? But there is a massive biological catch right there in Step 1.
And that catch is the number 7. Research shows the average person's working memory can uniquely hold only about 7 chunks of new information at a time. That perfectly explains why we can barely remember a grocery list without writing it down. Worse, we can only actively manipulate. Actually, scratch that. It's more like we can only actively juggle about 4 of those chunks simultaneously. This right here is the ultimate biological bottleneck of human potential.
And this brilliantly illustrates that very delicate pathway information has to take. You can see how the new information literally funnels into that tiny restricted working memory. If we try to cram way too much in at once, boom, cognitive overload occurs. The pathway is entirely blocked and learning stops dead in its tracks before the info ever has a chance to reach your long-term memory schemas.
So, let's contrast these two systems to really get the picture. Your working memory is extremely limited in capacity. It can only hold small amounts of new info for a very short, fleeting time. But your long-term memory? It's basically virtually limitless. It can organize vast amounts of stored info into incredibly complex schemas. Because there are no real limits when your brain is dealing with familiar information, the whole goal of any learning